All right, we're going to continue our discussion on carbon reservoirs. So the first activity that you did for this week was looking at what a reservoir is, and then applying that to the element carbon. So we're really focusing on carbon for the whole unit. Now with carbon reservoirs, that's the places in the Earth systems that carbon or the element carbon is going to be stored. So most of the carbon in the Earth system is found in these four reservoirs. And you can see that they're all circled here. So one reservoir is the atmosphere, one is terrestrial plants, one is rocks, soil, and sediment, and then the last one is oceans. So in the atmosphere, most of the carbon that we find in the atmosphere is going to be in the molecule CO2 right there. And that's going to be in a gas form. So that's not in a solid or a liquid, but in a gaseous form. CO2 can then be taken up by terrestrial plants, and that CO2 gets converted into plant material. Think of the trunk of a tree or the leaves. All plants are going to take up carbon and be a reservoir for carbon, but really we want to think of the trees. The trees are really the plants that hold the most carbon. Okay. We also have a lot of carbon in the rock, soil, and sediment. If we look at the whole Earth, most of the Earth is a big rocky ball. So the majority of carbon in these systems is going to be found in the rocks, soil, and sediment. That is all locked up in the solid rocks. It's going to be our largest reservoir, or our largest place where this carbon is stored. And then the final one is going to be oceans. Oceans, you're going to find it in phytoplankton primarily, but also you'll find it in some other sea creatures that have used the carbon to make parts of their body. So again, we're talking about solid, carbon as a solid, not carbon as a gas or a liquid. The question now is, how does it go back and forth between each of these three systems? So how does it get from the atmosphere to the terrestrial plants, or how does it get from the atmosphere to the oceans, or from the oceans to the rock? And we're going to cover each of those individually.
Okay, so the first transfer of carbon that we're going to see between reservoirs is going to be photosynthesis. So you've learned about photosynthesis before. Hopefully what you remember is that plants will take up CO2 from the atmosphere in order to make their sugars. And we see that in this equation here, where carbon dioxide and water are taken up by plants to make sugar and oxygen. Now, the oxygen is what we use to breathe, right? And all the other creatures that are going to be utilizing oxygen are getting it from plants as a byproduct of photosynthesis. So the carbon gets moved into the plants. This is the plant material, the woody fibers and trunks of the trees. And that holds quite a bit of material. It's also going to go from the atmosphere, which it's still in the form of CO2. It's still carbon dioxide. It's going to go from the atmosphere down into the oceans. So it can dissolve into the ocean water and then be taken up by phytoplankton, which are just, if you think about it, small plants. And they go through photosynthesis and they make their own sugars, but there's so much phytoplankton in the oceans that it actually accounts for a pretty large source or sink of carbon. Okay, so photosynthesis is the process that takes carbon from the atmosphere into terrestrial plants and from the atmosphere into the oceans into phytoplankton. Okay, so the next part of this process, this movement of carbon, comes in the form of respiration. So we'll talk about respiration first. Respiration is when we utilize the foods that we've eaten, we burn, use oxygen to burn up those foods to get energy. So here's our sugar right there. Here's our oxygen. We get energy out of this. And guess what? Plants do the exact same thing. They've made their sugars, they haven't eaten their sugars, but they still use those sugars, plus they use oxygen in order to get energy. Now, just like us, plants will respire or give off CO2. And that CO2 is going to go back up into the atmosphere. So that goes back up into the atmosphere as gas, right? Another thing that comes out of this is water. So this is the reverse of what we saw with photosynthesis. So now we have movement of carbon back and forth between terrestrial plants and the atmosphere. Another way that carbon moves from terrestrial plants is through decomposition. So the plants die, the tree dies, and slowly over time it's going to decompose. As it decomposes, that carbon will get broken down and end up as soil and sediment, and eventually through geologic processes as rock. Okay, so the carbon has gone from the atmosphere to the terrestrial plants. The terrestrial plants died, and then they got put into the rock, soil, and sediment. And down here you can see oil and coal deposits. And if you remember, our fossil fuels are just the leftover remains of trees that lived a long, long time ago. Sometimes people say it's dinosaurs. It's not dinosaurs. It's the plants that were around, during the beginning or even before the time of the dinosaurs, when these plants and trees covered the globe. That's your oil and coal deposits. The next step is to find out where they go from some of the other spheres that we've talked about. Okay, the next process is weathering. So now we're going from the rock, soil, and sediment into the oceans. And this happens slowly over time, but it's been always going on since the Earth cooled and we had a crust and water that would cause erosion. So what happens is through weathering, primarily water, but wind also is part of it, the water slowly breaks down the rocks and carries away the soil. That's usually done through rivers and streams and lakes and such. Eventually, most of it will make its way to the oceans. So that carbon that was locked up in that rock gets transported into the ocean. And you can see there's a physical and chemical breakdown of the rock. That rock or carbonate, the CO3, can then get utilized by creatures that are in the ocean. If that rock's broken down enough into its chemical components, then creatures in the ocean can utilize that to help make things like shells and hard parts within their structure. Okay, the last process that we're talking about here is sedimentation, and you can see in this visual we have sedimentation going on in the oceans. And what you have is all these marine organisms, all these small microscopic marine organisms or larger organisms that have things like shells. As they die and start to decompose, start to fall apart, the carbon that's locked up in their bodies, especially in those shells and hard surfaces, hard parts, will start to fall down to the ocean floor. And that gets layered up and layered and layered and layered and layered as more and more builds up over time. Eventually, that can be compressed into sedimentary rock. So it can be layered up so much, and so much material can be stacked on top of it that it starts to get pressed and changed and actually formed into sedimentary rock. A good example of this is limestone. Limestone is made up of the leftover decomposed parts of seashells, and really, again, what we're talking about is the carbon, tracking that carbon from the seashells being pressed into this rock. So then it goes into our sphere over here with rock, soil, and sediment.